Hello, this is going to be a video about Viktor Schauberger, an Austrian forester whom you may or may not have heard about, whom I think is going to contribute a great deal to understanding the environment, not only from now, but well into the next century and beyond, because he had insights into the movement of nature and energies in nature, which I don't think anybody else ever managed to achieve, not that I've been aware about. Now, just before we continue, I want to say that this video will divide. I'm going to address Viktor Schauberger firstly from the historical point of view of what he actually did in his life, and then we'll go to discussion energy, which is fundamental to understanding Viktor Schauberger's series, and then we'll move on to water, to trees and light, and then a little bit of mathematics towards the end of it. I'll probably keep the mathematics pretty light. So first of all, we're going to go through an overview of Viktor's life fairly briefly. He was born of a long line of foresters his ancestors had been in the forest for about 400 years and looking after this area of forest, principally in Bohemia. And as a result, he had, so to speak, a genetic basis from which to interest himself in forestry. It was in his blood. And so it was very natural that when he finally was able to decide for himself what career or what path he wanted to follow in life, he chose forestry. He very much was against what you might call formal education, having seen how his elder two brothers had been sort of, in his view, perverted, that their minds had changed because they had been to university. He didn't want to do that, and he wanted to study nature in the forest and be with nature in the forest. The family motto of the whole Schauberger family was Fides in silvis silentibus, which means have faith in the silent forest, or the silence of the forest. And as we'll see a little later when it comes to energy, we'll find out what this silence in fact means. Now, Viktor had occasion, because of where he was in that part of Austria, which was in Steiermark, he had occasion to visit areas of forestry which had so far not been touched by human hand. And as a result, he was able to observe phenomena there which today probably cannot be found, at least they would only be very rare, because the environment has deteriorated to such an extent that these things can no longer be seen. And as a result of these observations, he then began to evolve theories about the interaction of energies, about the movement of water, the natural movement of water, and also fundamentally that energy was primary and the physical effect secondary. In our present view of the world, we seem to take the physical artifact as being the primary one, and whatever energy created it is uninteresting to us. And so, in fact, what we do in terms of the environment is a sort of band-aid policy of fighting effect with effect with effect, and never going back to the fundamental cause. Now, in his early life, he rose very quickly to the rank of forest warden, and there he was taken into the employ of Count Prince Adolf zu Schaumburg-Lippe, who was a German nobleman who had acquired estates in Austria. And this man, this would have been just after the First World War, I suppose about 22, and Count Lippe had spent a lot of money on the gaming tables in Monte Carlo, his wife particularly, and he always had to find money to recoup the losses, particularly from his wife, fortunately. And so the only way that was open to him in order to recover these was to cut down the forest. And he had large areas of forest which had so far been untouched, but the access to them was very difficult. And the technique in those days of transferring logs from the remote forest to wherever the sawmill was to cut them and throw them in whatever stream was handy and hope that some of the logs would get down there in a condition that they could still be used for saw logs. Of course, this was very wasteful. And this is something that disturbed Viktor greatly. And so he had already made some designs for a log flume made out of timber, which was very easy to construct and which would then transport logs from the forest to the valley in a perfect condition. This was done at the behest of Count Schauberger, who said, if you build this thing, I mean, this was a contract, and Viktor put forward that he would build it. It was accepted by the Count, and the Count said, well, you pay for it, but if it works, I'll pay you for it. If it doesn't work, you can take it down at your own expense. Well, Viktor accepted this challenge, and rumor of his operations got out to Vienna and the Institute of Hydraulics, and there was a certain amount of anger on the part of the established science. Why hadn't they been asked to build this flume? Well, anyway, the upshot of it was that the flume was built, and the first day it was in operation, it exceeded its minimum delivery of 1,000 logs by 600 logs, and so Viktor Schauberger was paid. Now, the principles on which this operated was that there was firstly, at the top of the flume, there was a holding basin, which was egg-shaped like this. Now, the egg-shaped part of it was important because when the water was let into it, no pressure was exerted on the outside. When this was actually opened, all the hydrologists from Vienna, of course the prince and princess himself, or the count and countess as it were, and any other dignitaries, the local councillors and so on, everybody was invited to the opening of this log flume. And when they saw the rather flimsy structure, this is only very schematic and it may not be quite exactly right because the existing one has already been destroyed, they said, well, you know, what's going to happen with this? That wall is far too flimsy, it's going to break. And Viktor said, no, it won't. And to prove it, he said, I'll go and stand out on the edge of it when we let the water in. And if I'm wrong, then the world has been rid of another fool. So he went and stood here when the water was let in. And actually, the water came in at a height of about 4 meters height of water into this basin, which was 18 meters deep. And when it came in, it curled around the sides and around the bottom. And so by the time it got to here, it had a sort of wave which flowed back in the opposite direction and resisted the pressure of the oncoming water, and the water held. Now, everybody thought Viktor had been nuts to stand out there, but once it came and it stabilized, they realized that he had something, and actually when it was checked mathematically from a statical point of view, it was 12 times stronger than it need have been. Now, the flume itself, coming out of this holding basin, was a half egg shape. Now, it's difficult, I'm sorry there are no better diagrams or photographs than this, no clearer ones, but the actual structure of the flume, and we'll come on to that in more detail later, was built out of wood. It was half egg shaped. It followed, as far as possible, the path of the river in the valley where it was being built, because Viktor said, you always have to copy nature. You have to comprehend and copy nature. You have to see what nature is doing and copy her. And in this situation, the water likes to flow like this, so we shall copy it. And the log flume followed the same curves as the valley. Now, the way that it worked was that from the holding basin, this is the egg-shaped holding basin, again slightly differently shown, and the water stratifies according to temperature, so that the very warmest water is at the top, and it gets colder and colder towards the bottom. Eventually, the bottom water would have probably the temperature of about plus 4 degrees centigrade, or in Fahrenheit, that's 39.2. This is a very vital temperature as far as Viktor Schauberger's theories are concerned, and again, we'll come back and see why that is a little later on. Now, it was important for Viktor that in the log flume, various temperatures of water were used, because according to the Archimedean principle of the denser carrying the lighter, when water is made to flow in a longitudinal vortex, then at the very center of the vortex, you have the heaviest core water, surrounded by warmer and warmer layers of water. And it was this that he understood, which nobody else understood at the time, which enabled him to transport logs which were heavier than water. Sinkers, as they were called. They were green logs. Now, by by taking water out firstly of the top layers of the holding basin, he then took water out of the two lower levels, so that he got a mix of water. But as water is at a different temperature don't mix for quite a long period of time, this difference in density stayed for quite a considerable period during the flow. Now, what happened was, because the core water is denser, it flows faster, and when the log, which is in the center of the core water, it has a cut-off end, so that in front of it an area of suction is created, which actually pulls the log through the water. In order to maintain this difference in temperature, Viktor used to allow what he called energy water in from time to time, depending on the exposure to the sun. If the flume went into the sun, he would have to do it more quickly than if the flume flowed in the shade, because the temperature was very critical here. And so periodically, some of the water would be let out, and new water would be allowed in. Again, it was probably introduced tangentially, so that a vortex was automatically created when the water was introduced. As a result, and also to aid the system so that the logs could actually flow down smoothly, he had rifled bends in the pipe, which would throw the water on the right-hand bed, would make it curl in a clockwise vortex looking down the stream, and a left-hand bed anti-clockwise. And the effect of this was, at a right-hand bend, for instance, the vortex would go this way, and it would push the log from the side towards the center. So the logs never even touched the side of this. It was a marvelous development. It was, as far as the experts were concerned, hydraulically inexplicable. And he built about 9 of these during the early 1920s and early 30s. And now the principal thing about these log flumes was that he used the energy of the vortex. Now, the vortex is very important in flowing water, because water naturally likes to move in vortices. And it is these vortices that, and the energies within them, that the trout uses to stay in one place, the so-called stationary trout, which stays in one place in the stream, even though the water is flowing very fast. I'm going to leave that on for a minute. I won't come back, and I'll talk to it in a moment. Now, the thing that Viktor did perceive, which was very important to him, and was the realization that in any natural phenomenon, there are always 2 energies which are interactive. And so you have, on the one hand, cold and heat, or you have gravity and levity, or you have magnetism and electricity, or you have pressure and suction. So all these things always formed the unity, and whatever happened in any energetic interaction was always a reciprocal proportion between the 2, that if one was slightly less, then the other was more, and so on. But they couldn't be seen in isolation. They had always to be taken into account. And so in a naturally flowing watercourse, the river would flow down from the spring under the effect of gravity. But at the same time, there would be another movement of energy back up to the source, which was the movement of levity in the opposite direction. And levity, or levitation, forces of levitation, he associated also with what he called biomagnetism, which was a life force, which was the force that made things stand up. It was why trees grow into the sky. It is why fish swim one way up and not the other way up. It's why plants grow. And everything everything that moves anything upwards was this biomagnetic life force. And as the life force diminishes, of course, then things tend to drop further to the ground, because then they are under the influence of what he would have called the death force, gravity, which is the one which drags everything down. Now, in a very healthily flowing river, because the state of health is extreme, then the life energy, or the biomagnetic energy, or the levitational energy is at a maximum. And in this case, it moves from the mouth of the river right up to the source with a lot of force. And in the process, it creates an invisible energetic jump, as it were, or an invisible energetic vortex, which trout and salmon use to overcome waterfalls. Because Viktor came to a point high up in the plateau in the area that he was in charge of. He came across a stream, and when he put his staff in the stream, he started a trout, and the trout swept upstream very fast. And he said, well, firstly, how did the trout get there? Because I know that a kilometer downstream there's a waterfall which falls 60 meters, and where the water goes to mist. So how did this fish get here? Because there's no other way to get here. And that started him to think about how these energies interact. Now, the trout stays in the stream also because of the levitational forces which move. The stream is flowing this way, and also because of the forces which move in the other direction, the levitation energies. But there's another factor too, which involves the turbulence in water. According to Viktor Schauberger, every particle of water is, the movement is associated a particular velocity with a particular temperature. Now, if the velocity is exceeded relative to the temperature of the particle of water, then turbulence automatically results. And this turbulence is in fact the automatic brake in flowing water, which prevents water running down a very steep gradient from breaking out of its banks, from actually overrunning itself so it flows too fast. It always comes in as the automatic brake in flowing water, so that when a particle of water exceeds a certain velocity relative to the temperature of that particle of water, then turbulence manifests itself. Now, a trout will always stay in the center of the central axis of flow, where the water is coolest, because that is where the energy is greatest, because with water at a temperature of plus 4 degrees or 39 degrees Fahrenheit, that is its state of greatest energy content. And the trout sits in this flow of water, and it just has its jaws open, and all the food is moving down this vortex and goes straight into its mouth, and it doesn't have to do anything. That's why they sit there so happily and so quietly. But when, if you look at these lines here, these are the flow lines of the water. And when the water flows and encounters the trout's body, then close to the trout's body there's an acceleration of the water due to pressure initially. And in the process, the affected particles of water exceed their critical velocity, and then turbulence occurs on the rear flank of the trout. And the turbulence, in a sense, has a rotation so that part of the movement of the forces of that turbulence press the trout's body forwards, and it's able to stay in the flow and in a stationary position. The other aspect of it is that in the process of breathing, it removes the oxygen from the water through the gills. And when this oxygen-deficient water comes out of the gills, then it wants to grab any dissolved oxygen which is in the water, and in the process it expands that particular, the water molecule, so to speak, expands, and this pressure again happens at the reverse, at the rear of the trout, so that the trout goes forward rather like a slippery soap. It just darts forward, and it's actually held there by the water itself. Another factor which we need to look at also is that the actual shape of the trout's body is formed of a composite of 3 egg forms. There's one seen from the side, viewed from the top, and viewed from the front. Now, this egg shape seems to have an affinity with vortical flow, and it offers less resistance to flow than other shapes do. And we will also have a look at this perhaps a little later on another diagram. But with the mathematics of Walter Schauberger, who was Viktor Schauberger's son, a physicist, it's possible also to create similar egg-shaped forms, fish forms. And this one these just show some which I created on my computer, these ones. And that is by combining 2 eggs and forming the third one, which is what you see from the front. So you can see that these shapes actually are very fish-like, and they are as a result of Walter Schauberger's mathematics, which we will address a little later on. Now, in his remote forest house, Viktor didn't have any power, and of course he wanted to have electricity, and this was one of his very first inventions, a water jet turbine. in which he was able to generate a certain amount of energy, electricity, using only 1/10 of the normal amount of water required to produce the same amount of power with conventional systems of hydroelectric power. The water was made to flow down this rifled conical pipe, where it impacted on an impeller, which is this rather shell-like form here. And the impeller, in fact, was made of grooves which faced upwards. So when the water impacted on them, they caused a rotation. And these tails at the end of it were where the last bit of momentum of the water was captured, and then the water just fell off. And this was extremely efficient, as I said, and it produced a 9-fold increase in power for the same amount of water. A group of people, enthusiasts in Austria, whom I visited when I was there, were building a combination of egg shape and hyperbolic cone. Again, we'll come and talk about these later. But they were going to put, I think, this impeller at the bottom of it to generate energy. That was their... they hadn't actually got the thing fitted when I was there, but there's an egg here, and then it turns into a hyperbolic cone, which is actually a cone with curved sides. Later on, the egg shapes, as we're still sort of on the subject of egg shapes, they became very important for Viktor's devices. This is a device built in Sweden for purifying water and for raising water from sort of standard surface water quality to high-grade spring water quality. There's no diagram inside this one, but the following diagram is nearly the same, and it'll give you an insight into what was actually happening inside there. The most important ingredient in high-quality spring water is carbonic acid or carbon dioxide, and that comes in through this pipe. Now, the normal surface water is brought in around the side here, and it feeds up through these sort of nested rilled bowls, and these are caused to rotate. And in the process of rotation, they are forced towards the outside with centrifugal force. At the same time, because of the waviform nature of the space between these two, they are also made to rotate in a centripetal fashion, so that the water is exposed to both centrifugal and centripetal force, again using the two forces in conjunction with each other. Coming into this cavity, a vortex is formed inside, and the carbonic acid or the carbon dioxide, whether it is carbonic acid or carbon dioxide is again dependent on temperature and pressure, is fed in, and because of this vortical movement, it is actually sucked into the water. It's not put under pressure. And so that with a system like this, you could create your own mineral waters, your own true mineral waters, but the bubbles would stay in there. They don't come off when you take the lid off, because the carbon dioxide, has been infused under natural process into the water. So that was the principle of the previous Swedish machine that we saw, but this one was also used for raising water. And the water, once by making this movement, was endowed also with this levitational energy that we spoke of before. And at a certain point, when the energy is high enough, when it's reached a certain point, then the water rises up the central pipe. All that was needed to drive this was a fairly modest electric motor. And according to Viktor, the water could be raised to almost any desired height with this process. There is more involved in it, but I don't think I'm going to be able to go into that because there are other things that I also want to address with Viktor's work. One of the ways of testing the quality of water was this double water jet gadget, which he built first, or his son Viktor Schauberger built first in Nuremberg in 1938, although I think it's a development of Lord Kelvin's original experiment early this century or in the late 19th century. Here, through two needle jets. I mean, these are hyperdynamic needles. Water is made to fall through two insulated cylinders with brass lined into two receptacles, which are also made out of, they're also insulated. In this case, they're insulated with paraffin wax. But each of them has a brass strip in the bottom, which is connected diagonally to one of the, or other of the cylinders. And when water falls down through there, at first you see the jet come straight down, and then after a while you can't see the water appear below here at all. It disappears. A charge builds, and if you connect, bring two wires together, one with a positive charge and one with a negative charge, you can get a spark which will jump about an inch. I got that now. In terms of voltages, that is about 60,000 volts. And Victor used this machine to determine the quality of water because it could also be employed in conjunction with what is called an electroscope, which detects the presence of a static, either positive or negative field in the atmosphere, and then there's a part of it which flaps every time it is exposed to the field, so to speak. You bring one of these wires, you touch the top of the electroscope, and then it flaps up like that and then drops away. You touch it again and so on. Well, now, with this machine, 1 liter of very high quality water could be passed through it 150 times before the electroscope stopped flapping, whereas low quality water would only maybe pass through 5, 6, 10 times, and then the thing would stop flapping. So he used it to determine the life force within the water. Another facet of this gadget is that it shows you, again, what happens in thunderstorms and how the charge is built up in thunderstorms, how the updrafts and downdrafts are created in thunderstorms, because the water actually, you see, when like charges repel each other, so when it's falling down from the jet at the top, a charge is generated, and all the like charges repel each other, so gradually the water molecules move away, and as a field builds at the bottom, then they can't go down, they have to go up. And so you have this movement, which eventually also can be a circulation. And in the middle of this, I suppose, you can also have this electric discharge, which shows you in a very simple form how lightning works and why it occurs up there, and why it also can be so huge. Because you have to think that this is not, as a machine is about this high, the fall distance is about this far, and with that I was able to generate a spark which jumped an inch. Now that's, as I said, 40 to 60,000 volts. Then Victor also, towards the end of his period, built these two, they're so-called flying saucers. This one, either one of them, I think, flew. They're both actually the same machine, but they've got different caps on them. He kept on modifying it. This was either called the repulsine or the repulsator, because the forces were active in them were the forces of recoil, of retropulsion. And these were achieved, again, using centrifugal force and centripetal force operating on the same axis. And in the following diagram, it will become a little bit more apparent how that works, because this one is to do with the biotechnical submarine, as he called it. The water would enter here in the front, and it would pass between these meandering membranes. They're rather like a sort of loudspeaker diaphragm with a reducing, they narrowed towards the outside, and of course the whole thing rotated. So in the process, the water was sucked in, it was then expelled towards the outside under centrifugal pressure, but at the same time as going towards the outside, it was made to vorticate centripetally. And so the water that came out of the outlets was firstly extremely cold, because in the process there was an immense cooling, and again more or less the same effect took place behind the submarine as took place behind the trout. So moreover, because of the rotating thing, a suction was created in front of the machine, a pressure behind, and so the thing actually moved through the water. What in fact happened, or as far as one can determine what happened inside this nose cone, that's a bit more detail. is that there's a process of concentration, condensation, and then expansion, condensation and expansion. Now, Viktor determined that there were two other forms of temperature. Normally, the usual temperatures we think of rising and expanding heat, falling and concentrating cold. But he said there was also falling and concentrating heat and rising and expanding cold. Now, those are the two temperature forms which are responsible, in fact, for life on this Earth. Because if you're outside in space, we have falling concentrating heat as you approach the Earth's surface, and rising and expanding cold as you go in the opposite direction. On the other hand, mostly with our technical systems, we have rising heat, rising and expanding heat, and falling and concentrating cold, so that in technical controlled environments, we usually have cold feet and a hot head. Whereas if we were able to turn this process around and have a natural system of temperature, then we'd have a cool head and warm feet. Now, in this process of here, it was possible to cut out, to swap from falling and concentrating cold into rising and expanding cold without cut out the heat element altogether. And so here, in this machine, you had falling and concentrating cold because it was a centripetal vortical action from the outside inwards. Passing through there, then it would become the rising and expanding form of cold. So that in fact, from here to there, going through these series of processes, in other machines as well, Viktor was able to take, say, 20-degree water and cool it to 4 degrees in a matter of seconds, simply by pushing it through this system. Now, the effect of this, of course, is because of the concentration, because of the condensation of water, or the densation of water, then there was always more room for more water to be sucked in at the other end. In fact, he spoke eventually of a process of creating the void, of causing such extreme densation that the elements, the physical substances, reverted to their energetic state and they ceased to exist as occupying space in the physical world. That created even greater suction. And of course, when they came out the other side, then the expansion was that much greater, so the whole thing moved through the water much faster. I hope this makes some sense. Then he turned also his, in 1948, he turned his mind to agriculture, because at the time, just after the war in Germany, food was a problem. And so he invented what was called the golden plow, or the bio-plow, which had a different form, because he felt that, from his understanding, that the plows which were used in those days, or the conventional plow, actually sheared the capillaries in the soil, which were the sources through which nutrients were supplied from the groundwater through upwards to the roots of the plants, and they cut them off. Also, because they were made of metal, then certain electrolytic currents were generated in the soil, which partially decomposed the water molecule and disturbed the nutrients in the soil. And so he invented this plow, which was actually, I think, copper phosphor bronze. This is a much later model. And the idea of this one was to slice through the earth. And because it was made of copper, of course, it didn't create any of these electrolytic currents. And in a field outside Salzburg, where he did several trials, the field was plowed in strips with a copper plow, steel plow, copper plow, steel plow, and so on. And when finally the crop grew up, it was found that there was a difference in height of maybe 6-9 inches between the iron and the copper. And as he achieved most remarkable yields, increases in yields of up to maybe 40% in some cases. This just shows an ear of rye with 104 grains on it. That was the sort of length he was getting with these things. A potato which weighed 430 grams, so that would be about a pound, I suppose, with 20 eyes in it. But that was very high quality produce, so there was no need for sprays or anything. And so it was quite telling that just by changing your steel or sheeting your steel plow with copper or phosphor bronze, which is better because it resists rubbing and it doesn't deteriorate so quickly as copper, not as soft, then you can achieve huge increases in fertility. And another aspect to do with the ploughing, instead of ploughing it in straight lines, which is normally done, it was very important to look to understand the orientation of the ploughing, so that fundamentally the furrows went north-south, so that when the sun moved across the heavens, one side, the whole plant firstly got an alternation in light and shadow, so did the soil. But by introducing the curves in it, then even this pattern of light and shade and exposure to the sun was even more reduced, so that there was a far better balance of light and shade, and therefore the moisture was conserved in the soil. He also had other ideas about composting. He was very fond of egg shapes, and we'll find out maybe a little bit more about those. This was the egg-shaped compost system, and he had again a completely different view of how these should be done. Normally when we compost and the temperatures start to build up in the compost heap, we think, oh well, it's cooking, it's going to be good. But he said this temperature is very bad, because in order to increase fertility, not just to maintain it, you have to have a cold fermentation process. That means that you've got to keep the heat down as far as possible. Because if you keep the heat down, then earthworms will migrate into the compost heap much earlier on. They will work the soil inside it, and when they finally die out, then their bodies, which are full of protein, will have enriched your compost heap all that much more. But if you have allowed the compost heap to heat up, then the worms will not come in at all. By putting it under the tree like this, then the compost not only fertilized the tree, it was built up in layers of gravel and dry vegetable matter, not damp vegetable matter, because the idea was to keep water out of it as far as possible. And there were newspapers wrapped around the trunk of the tree, which finally rotted out, allowing a passage of air to come right down and aerate the whole system. And the outside of it was covered with clay, so that as far as possible, rainwater would not penetrate into it, because the rainwater, being virtually pure water, seeks after all the elements it can get, and then it would actually remove minerals and trace elements from the compost heap, which means that they would not then be available for whatever you wanted to grow with it. And so it was protected under the tree within the drip line, so that and eventually in the end of autumn or early winter, you would break it down and put it over the fields. Another system, again, he used for fertilizing the land, were these devices. They were egg-shaped devices which are actually in the ground. They were cavities, and he had a motor, and he induced a movement of water inside. This, I suppose, would have been about 2 meters deep, about 6 feet. And into this water, he placed some filings of zinc and copper. And through the galvanic interaction of these, energies were also infused into the water, which allowed other interactions to take place. And this water was able then to be used. It's in a sense something similar to the biodynamic process of mixing. Then after that would take about 3 days, 4 days to prepare, and then it would be spread out on the fields or hosed out towards the evening, but never when the sun was there. The other one was a similar arrangement, but it didn't have a motor in it, and it had a number of different elements put in it. Again, copper, a certain amount of silver. These are all small filings, not huge amounts. And this generated energies which propagated themselves laterally through the soil and enhanced the processes of germination. Because you see, Victor again saw the earth as the mother, the life giver, the giver of life, who was always fertilized by the sun. The sun's rays enter the earth and trigger the processes, so that the movement, the vertical movement of the sun, then becomes in the rotund, so what you might call the expansion of the womb, as it were. For firstly, we have the insemination, which is the energy, the information from the sun, which then is converted into a rotund expansion. And at the surface of the earth, this actually appears to us to be horizontal, because I mean, the Earth is quite large, but in fact, if you were looking at it from the Earth as a whole, then these energies would move around parallel to the Earth's surface, although they come pulsing out from the inside, and it is these pulsations which are the cause of, the spring, the blossoming in spring. And of course, there is a period of rest and a period of activity. So within these vessels, he generated energies which propagated laterally, which were these female energies, which enhanced the whole process of growth and fertility. In 1952, he wanted to have his ideas on the movement of water tested scientifically, because he was fed up with people saying, "Oh, it's all a lot of rubbish, gobbledygook, and what are you talking about?" And so he produced a series of pipes which he had fabricated himself at his own expense, and they have various configurations. This is a tapering rifled spiral pipe. This is a cylindrical one. This one is a double helical spiral pipe, which is about the same as this one. And these other ones were the normal straight pipes in order to compare the differences in flow. This up here is the leveling vessel, where a constant head of water was maintained with a flexible tube at each end into which the pipe under test was inserted to see what happened. These three tubes here calibrated, firstly, the one on the left-hand side gave you the head of water available, and these ones here registered the drop-in, registered the increase in friction or the drop-in pressure as a result of the water passing through the pipe. So if it showed a low value, that means that there was a large increase in friction. On the other hand, if the figures, the pipes here indicated above this one, that meant that the water was actually generating energy. And the interesting thing about this pipe, it has this particular cross-section, which is more easily seen in this patent application of Victor's. It's a pipe with, like an egg shape. Again, we always come back to the eggs, but a quarter of it is, or quadrant of it, is taken out and inverted. And this inversion, it rotates around the pipe, which is itself a kudu, like a kudu horn. And the water passing through this one produced some very interesting results, because as plotted on the graph, the one we're most interested in is the bottom one. But these two here are a straight glass pipe, and this is a straight copper pipe. And you can see the frictional values increase this way, and the flow velocity, or the volume of flow, increases in that direction. So that the glass pipe and the copper straight pipe, virtually the friction increases constantly. However, with the spiral helical pipe, then you have this pulsation, this periodicity in the flow, where at one point the friction increases and then it reduces. In my view, where it's shown in blue is where the suction is increasing, and where it is red, that's where the pressure is increasing. And at 2 points on here, you can see that the actual measured values dip below the negative line, which means that in that area, the water was generating, producing energy. In fact, Professor Purple, who carried out these experiments, referred to this phenomenon as negative friction. And this meant that the water flowing through the pipe and the form of the pipe itself were in a state of harmony. And in that state of resonance, there was no friction. No friction was generated in the pipe. And under the test figures, this zero value for friction occurred 3 times, although it doesn't say that it doesn't show here, which is slightly dishonest. It doesn't show the negative values on there, which should be there. Having moved very briefly, I'm afraid, through the history of Viktor Schauberger, and I'm sorry, I realize I didn't put enough years and dates in it, but that more or less covers the span of his life. The principal factor that we have to understand with Viktor's theories is it is always the energy which comes first. It is the movement of energy which is important. And if you can understand the movement of energy, if you can guide it or create forms in which the energy would like to function, to flow, if you copy what happens in nature, then by and large your problems of energy are solved. Now, if we look at historically what has happened to humanity, the progress of humanity over the time, we can see that there are two paths which are virtually parallel. When our technology, so to speak, and the nature's technology or nature's evolution were virtually on parallel paths, because mankind fundamentally, or humankind shall I say, was living in harmony with nature, and so, or more in harmony with nature, and so whatever things he did which were unnatural, or whatever systems he used which were unnatural, really didn't have any effect on nature at all. But we, in our system of technology, we use predominantly explosion as the motive power. And this is totally contrary to nature's use of energy, because she uses implosion fundamentally. And implosion is associated with the biomagnetism, with levitation, and so on. It is the uplifting side of life, whereas explosion is associated with gravity, with electricity, with disintegration. And the system of energy we are using today is essentially based on centrifugal ideology, as Viktor called it, and explosive, which has explosive effects. And this seeks always to destroy. And I think out of those, this centrifugal ideology has also arrived the idea of a competitive nature, because it is a divisive process. Now, on the other hand, nature uses this integrating movement, this integration of energy, in order to build higher and higher forms. So we have always been striving with our centrifugal technology to build systems which are energy efficient. And according to Viktor Schauberger, who had a meeting once with the head of Mercedes-Benz, and he was discussing the efficiency of petrol engines, of combustion engines generally, Walter said, well, I believe, your greatest efficiency is about 20%. And Dr. Fritz Kortegas said, no, I'm sorry, you're wrong, it's about 13%. Now, if you think of, that means that 13% of the energy put into that car was actually used for propulsion. All the other 87% was totally wasted. And that is the system into which we are locked, because if you put in 100 energy units into a given system using centrifugal technology and explosive technology, then what you get as a return is only 13 usable units. 13%. If you invest that 13% in the same system, then what you get back is only 1.69%. And so it is a self-annihilating technology into which we are presently locked at the moment. And what it requires is a change away from the explosive technology to an implosive technology, which will once again start integrating. Now, in this process, we can see that with the increase in our technology, we are, and its effects, we are gradually accelerating a downward curve towards entropy, because this process of division reduces things to their smaller and smaller components, to greater states of uniformity. And finally, in uniformity, there is no life at all, because there are no differences. Life is made out of differences. So the upward green line here is nature's process of ectropy, in which higher and more complex systems are built on lower ones. And in a sense, it's a far more stable system, because the more complex it is, the more diversified it is, the more legs you have to stand on. So if one accidentally gets pulled out, then the whole thing doesn't collapse. Whereas with a system which is going further and further towards uniformity, then if one leg pulls out, then you have a very serious problem on your hands. In terms of the actual use of energy, just a few parallels need to be drawn between, how we use energy and how nature uses it. Now, for a human being, needs their energy requirement for 1 year is about 1,000 kilowatt hours, and 1,000 kilowatt hours is also what averagely falls per square meter on the sun, the energy from the sun, which averagely falls per square meter. So if a human being was able to transmute the energy from the sun directly into energy, its energy requirement would be satisfied. Coupled with this requirement of 1,000 kilowatt hours of energy, there's also an oxygen consumption of 260 kilograms a year. which ends up being about, I think on this thing it's 29.7 grams an hour. And a car, on the other hand, when it's driving, I've got the figures here, driving at an average speed of 50 kilometers an hour, consumes within about 3 hours the energy that a human requires for a full year. Not only that, but it consumes also 750 times the amount of oxygen that a human being requires. So that in fact, when you sit in your car, you are driving, not only are you wasting energy because you're only functioning at 13% efficiency, but also there are 750 oxygen breathing slaves sitting in the car as you drive along. And when you extrapolate this worldwide into the quantity of oxygen consumption, then I think one seriously has to wonder how much oxygen is actually still going to be available to us, because it is only produced by the forest and by vegetation. And if we cut down the forest, then of course we remove the amount of oxygen which is produced. I think, and perhaps, when they first measured the quantity of available oxygen, there was plenty up at 100 kilometers, and now if they measured it, it would be considerably lower. But because we're living in the very bottom of this bucket, so to speak, we didn't notice that it's actually getting lower. I think it would be interesting to make some research into this area. Now, again, what is, again, something that seems to have been so obvious to all of us, and because there's any number of examples, are all the spiral forms that there are in nature. These drawings have been taken from a book published in 1908 by a man called John Bell Pettigrew. But if you look at them, and I'm not going to dwell on them for very long, I'm just going to pass them through, what you see in all of them is that there is no straight line, circle, and or point. So there none of these things can be drawn with any of the systems we usually use for designing whatever our technical artifacts are. Nature doesn't seem to have any use for straight lines. I mean, even in the galaxy, the same, that's the Whirlpool galaxy, it's overlaid actually with the hyperbolic spiral of Viktor Schauberger, which is in its simplest form, again, so that you can see the outside, from the outside to the inside movement, can also be mathematically defined. So most of these spiral forms can be reproduced in one form or another quite accurately mathematically. Again, you have another example, that's the eye of a hurricane. Again, we have this movement from the outside to the center, from practically no movement to very high movement, fast movement. And at the other end of the scale, it goes down to the DNA molecule. Again, all these vortical, helical phenomena we can see, but we have never tried to copy them. For some reason, they're all associated with energy, but we just don't do anything with it. We are so fixed in our attitude to explosion technology with pistons and rams and wheels and all sorts of things like that. We don't seem to have come to grips with the idea of spiral movement. Now, again, according to Viktor, you see energy is primary and the form is the secondary effect. So that you have let's say we have an energy path which is represented by these blue and red core spirals, so to speak, which intertwine, being the female and male energies associating to create life. And into this wake is drawn matter. But the matter part of it can only go for a certain distance before the form itself ceases, because I'm not a continuous form. I'm a form which is finite in shape, but the energy which is passing through me is actually moving all the time. I don't know where it comes from, whether it goes in through my feet and out my head or the other way around, but there comes a point where the physical aspect has to stop, although the energy path is always moving. So that energy creates the path through which it wants to flow in whatever situation it is. So energy is primary and the physical form is the secondary effect. And you can see how beautiful this looks like in a water vortex. I don't think too many people would have seen a vortex like that. But I mean, this, again, is the beautiful form which water creates when it is moving down a hyperbolic cone. the actual positions of all these nodules, so to speak, can be calculated mathematically. And it's very interesting to note, just as a point here, that in English, what supports the human body is called the spinal column. And in German, it's called the Wirbelsäule, and that translated directly into English means the spiral column. So that they think in German, what supports your structure physically is the spiral column, and in German, all the vertebrae are they're all called vortices. And that is a completely different light on the whole thing. And so here, in a sense, we have what you might call a spiral column, which is very, very beautiful to look at. Now, the manifestation of energy is, in my view, it starts with the focusing of energy on a point. Because when we see something grow, a seed gets planted, and so that it starts out, this movement of actual physical growth starts from something very small and grows something into very large. But the energy input has, so to speak, had to focus down into the small in order then to expand again into the large. And so this idea of the thing, as it were, which vibrates at certain frequencies, that comes from realms. Viktor talked of the fourth and fifth dimensions of being, was the formative energies which created the physical form through their concentration. Now, perhaps an analogy to show how the effect of higher energies function on lower energies is if I say, for instance, that the solar wind comes out from the sun, it impinges on the atmosphere of the Earth, and at that point there are certain thermal and dynamic interactions which creates clouds and starts to move the air around the Earth. Now the air, so I've come down already from one level, from solar wind to the air of the Earth. But the winds moving around the Earth affect the oceans. And their movement across the oceans, we create waves in the oceans. And so I've gone down yet another level. From the air, I've now gone down to the oceans, and to the water. And right at the bottom of the sea, or near shores of the sea, then this water creates ripples in the sand. Okay, so that you have a progression of formative energies which come down to manifest themselves in, so to speak, physical reality, which in this case is the sand, so to speak. So you can see that how the sun's energy finally can manifest itself in physical ripples in the sand, but it's very difficult to see how physical ripples in the sand would finally manifest themselves in the sun's energy, so that these higher dimensions of being, these higher dimensions of energy, are responsible for creating physical form. And so you can see that the physical form, for instance, of these shells here, starts at a point, that's where the focus of energy is, and then they all manifest themselves as they go out this way. This energy also, strangely enough, and this is only perhaps a happy accident, but I hit a piece of glass on the edge with a hammer. So I actually focused the energy at one point, and I did create the same sort of shell form. That just might have been that, but I thought it was fun. Now again, according to Viktor, the natural motion has three fundamental ingredients, types of motion. There's orbital motion, and rotational motion, and what he called circulational motion. And those are easiest, most simply explained in the planetary system, or by our Mother Earth, because the Mother Earth orbits around the Sun. At the same time, she rotates about her own axis, and at the same time, the magnetic energies flow through it. So we have three systems of energy, and Viktor called this the original motion. And in a sense, it was the primordial motion, but it was also the form-originating motion. It was the motion which was responsible for creating physical matter. And it, again, this type of motion could be further subdivided according to him, and this is where we come now a bit more to the difference between centrifugal force and centripetal force, because we'll go for one side first. This is what he called axial radial motion, and this is a movement where it starts at the center on the axis and moves out towards the outside, towards the radius. So you start in the center, and you gradually move out to the outside. And with this form of motion, then the friction increases with increasing velocity. So in a system like this, in order to keep it rotating, you always have to put in more and more and more and more energy. Whereas with the opposite system, and the key words for axial radial motion are disintegrating, decelerating, dissipating, destructive, divergent, loosening, friction-inducing, and diffuse power is noise. It's not harmonic. On the other hand, the other system is radial axial motion, which means you come in, so to speak, radially, or from the outside towards the inside, towards the central axis. And this is the process whereby energy is concentrated to form, to create something, or to produce power, or to produce energy. It's the same movement, obviously, as the vortex. And the key words for that are consolidating, accelerating, integrating, contracting, and the concentrated power is silence. Now, if you all go into the forest, there's the most immense creative energy at work, but it's extremely quiet. All these molecular and atomic interactions, all the growth that is happening, but it's quiet. So that the concentration of energy is creative. And I think probably anybody who writes books or composes music, or they need to have some silence, because otherwise there's no concentration up here. Once you get to the noise, then that's all had it, unless you're very gifted about concentrating your thoughts. Again, this spiral phenomenon is seen in the planetary system. This is actually a movement of all the planets over one full cycle of Saturn, so that you can see that even the normal presentation of the planets, where we're shown in an atlas as just being a sort of dinner plate-like flat thing with all the planets tucked around it, in fact, it's also a vortex moving through space, so that at no point in space is the Earth anywhere that it's ever been before. And so that all the conditions are electromagnetic and other energies, cosmic and so on, at any point are always different, so that anyone born, for instance, under those conditions has to, by that very token, be different from anybody else, so that there can be never any true repetition of the identical, because that would be a waste of energy, something which has already been done. If nature is an evolutive system, then something which has already been done, you don't want to do again, because you've done it. So you only learn, something only evolves by changing and transforming. And I think that one of the problems with our society today is that we try to fix things instead of allowing them to flow. It's becoming more flowing than it was, but there was tremendous break on any changing in ideas and so on. Now, this energy process, the energetic process, as we discussed a little earlier, is always the interaction between two antitheses, so that you have matter and spirit. Together they make the unity. Some of me is matter, some of me is spirit. And the combination of the two are me. At the same time, quantity times quality is also equal to unity, because each of us one here has different quantity, but the defining thing between us all, is, apart from the shape, is the quality. And so we are the sum total of the multiplication of our quantity times our quality. Nature doesn't add things, she always multiplies things, because you cannot add two things together if they're not the same. As no two things are identical, you can't say there are two of this, because there's only one. There's only ever one. And in the same way, there's only ever one in the answer between these things. Because if you take the equation 1 over n times n equals 1, n is any whole number. So 1 over 2 times 2 is equal to 1. Half is times 2 is 1. 1 over a million times a million is always 1. So you have thesis, antithesis, and the synthesis is the unity between them. And on this you can also see all the ones under red principally are the male-oriented ones, which Viktor Schauberger claims are the ones, once they get too powerful, then they're responsible for destruction. The blue ones are essentially the more female-oriented ones, and the blue ones have to predominate if evolution is to evolve rather than de-evolve, because if the red side getting up on top, I'll explain this a bit better. You see, oxygen, as he said, he thought was a lower form of sunlight. because it was the inseminator. It was that element which provoked growth or provoked decay. It could do one or the other. Now, under certain conditions, oxygen becomes passive. In water, it becomes passive once you have reached a temperature below about 9 degrees centigrade. I think that's about 48 Fahrenheit, if I remember rightly. And it becomes bound, the oxygen, dissolved oxygen in the water, becomes bound by the hydrogen atoms in it. And therefore, what results from that is firstly a healthy water, the regeneration of the water itself, the regeneration of life. But and the oxygen is passive, but once you get over a certain point, then oxygen becomes aggressive. And instead of being bound by the hydrogen, the oxygen binds the hydrogen. And it's when it gets to that point that disease and old pathogenic bacteria start to evolve. So if oxygen as the male force, so to speak, is uppermost, then associated with that is the destruction associated with over-maleness, or the predominance of male. On the other hand, if it's the other way around and oxygen is passive, then the femaleness is predominating. And of course, it's not interesting for women to have war and strife and everything else like that, because nothing happens. They are the bearers of the future. And we have got to arrive, in my view, at a world where it is largely governed by women. I mean, men shouldn't be thrown out the door. They have a value as well. But they shouldn't lead, because if we look back in history, when men have led, then there has only been destruction. Very few cases have there been anything really beneficial for humanity. And in terms of oxygen and this particular table, then, or pressure expansion, gravity, darkness, positive energy, and egoism, they're all on this side, you know. And when they get they predominate, then all the other finer things, really, the things which integrate, are all thrown out or become destroyed. In order to understand the mathematics of that a bit more easily, so that you can see how that actually works, this is a rectangular hyperbola. And so if we have the string length, which is the quantitative aspect here, we'll talk about quantity and quality, it makes it easier, and the blue is the quality, then if I have a square here, which has a quantitative aspect of 1 and a qualitative aspect of 1. So in a sense, I've got 1 times 1, which is 1 squared, okay, which is what that is. Now, if I reduce the quantity to a half, then automatically the quality is double. So I still have 1 squared. I still have a rectangle with the area of 1, so to speak. Or if I reduce the quantity to a third, then the quality is 3 times. On the other hand, we can flip it the other way, and I reduce the quality to a half, then I've got double the quantity. And so it's a very, very simple math, and it actually represents the relationship between quantity and quality, or radius and angular velocity, string length and pitch. It's all actually based on music. Viktor Schauberger called this system the tonal order of nature. And this is the very simplest diagram, and it's really combined with one spiral diagram. This is all you ever need to explain it. It's that simple. The answer is always 1. So it's really easy. I wish I'd known this when I was learning math. But with these energies, again, the formative power of these energies, we can see this in the pine cone, where we have a certain symmetry, but it's what I call a balanced imbalance, because here we have 5 spirals descending and 8 spirals ascending. The 5 are male because the uneven numbers are associated with maleness, because a man can't be divided, whereas female numbers are even because they can divide it into mother plus offspring. So there's a division, there's a possible division here. Now, so here again, even in the pine cone, we see that there are 2 energies which are interacting. You've got the female energy and the male energy. And where these 2 energies cross, where they cross each other, where they negate each other, where the male and female come together, that's where the seed is. That's where all the seeds are formed. All the seeds are under the places where these 2 things intersect. So that within the length of the pine cone, so to speak, the male energies, if we are looking at it from the point of view of the sun, they are high frequency, they're coming down, so they rotate much more frequently over what you might call the pine cone wavelength, whereas the female energies only go, in this instance, once. So in order for life to be created, the male energies have to slow down, and the female energies have to speed up, so to speak. So the male has to awaken the female energies and bring them up to a certain energy level, then the exchange takes place and life is created. And so many forms in nature, like the pine cone, are based on the so-called Fibonacci series, all of the proportions of which can be found in the pentagon. So that the proportions of the five proportion is 1 to 1.618033988. And so this, if the red is 1, represents 1, then the green here, B, represents 0.618. I'll just keep it short. Or if this is the red, then the green is the same. So the whole of the pentagon is loaded, as it were, with Fibonacci proportions of the golden section. And if you transfer this into terms of the balance of life, because you see, life cannot occur if everything's the same, if it's static. There has to be a state of balance which is quite labile, or that is sort of unstable. Now, here we see, using the same 5 proportions, that a weight of 1.618 having a certain distance away from this central pivot, which is actually 0.618, and another weight of 1 with a distance of 1 away from this pivot, then actually are in a state of balance because of the forces, the resolution of the forces. And when they both, you take them both together, then they have a value of 2.618, which is actually 1.618 squared. It's a most amazing number, this. So you have this dynamic balance, and this is necessary. This is the position between the extremes and the mean. And it's always in a state of adjustment, constant readjustment, because at every moment something is slightly different, so you have to adjust all the time. So what appears to us, for instance, to be a state of rest is actually an extremely high state of energy. I suppose a way that you could explain it is if you take a guitar string and you twang it, then firstly it moves from one side to the other. But as it comes to rest, as it were, then the movement comes faster and faster until finally it stops. But you don't know whether in fact it's not going even faster and faster when it apparently is still. You follow what I mean? So this, again, this dynamic balance of fires, and it's like the tightrope walker, because if evolution is a progressive movement, I have to be in balance before I can move forward. And if I'm a tightrope walker walking on, I've got to make sure I'm in balance before I can put the next foot forward. If I'm doing this or the other thing, there's no way that I'm going to move forward at all. So again, it's this movement, this centering, this mean position between two extremes. And Viktor attached an awful lot of importance to the Fibonacci series and to the pentagon, because he said it was important for creating what he called the cosmic egg. And he didn't actually describe how this was done, but the cosmic egg, if this is the cosmic egg, can be created by putting pins in these intersections of the inner part of the pentagon. One pin here, which is the same radius taken from the center as that one, and another pin at the bottom, and a loop of string around them, and then you can actually draw an egg shape, because the curvature here is different from the curvature at the top. Eventually we come back to the mathematics of the egg a little later on. This, the Fibonacci again, can be used to determine various leaf forms, so that you have a proportion of 1 to 1.618, 1 to 1.618, and so on. And depending on the angle between them, then depends on what sort of leaf shape you can get out of it, a small one, a large one. I mean, these are the very simplest things. Or in terms of the evolution of spirals or shells, like the Nautilus shell again. You have 1 to 1.618, or 1 to 1.618. It depends again on the angle at which you progress from one part of the proportion to the next, whether you have a spiral which goes out quite quickly or one which goes out quite slowly. But now we come to another section now, which is really mainly dealing with water. And although we have touched lightly on water in the previous part, this is more specifically to do with water. And the first thing that has to be understood in this regard is that water is a living substance and not just H2O, as we're all taught or have been taught at school. In order for life to be created, it cannot be created out of things which are not alive. And water is the most universal solvent. It's the most universal agent for the transfer and the mutation of elements, that is the forces from the sun, the forces from the earth, into life forms, because it permeates all of us, and all organic life has to have water, otherwise it doesn't exist. So water is the blood of this earth. Water is a living substance, and in Viktor's view, blood and sap and water are all the same things. They perform the same functions, although also in his view there are as many varieties of water as there are human beings and plants and animals. So it's not something which you can wrap up into a nice little package and say, that is water. In fact, many people have written books on water, and I think they still have not come to the bottom of what water actually is. It has this ability to combine with more substances than any other, and the nearest its counterpart is carbon, which can also make more molecular compounds and mix with more other elements than any other elements. So water and carbon, so to speak, and their interaction produce most of the living substances. Carbon, in this sense, being the mother substances of Viktor Schauberger as well. Water has got 3 states of aggregation. It can be solid, liquid, or gaseous, or that is in water vapor. And it contains 2 hydrogen atoms and 2 oxygen atoms, so the 2 hydrogen providing a double negative charge, and the oxygen providing a double positive charge. And because of the distribution of charge around the water molecule, the separation between the 2 hydrogen atoms is about 104 degrees, 104.35 degrees. Water has another phenomenon, that it is a dielectric. Pure waters can separate 2 charges. It can separate a positive charge and a negative charge in its very purest state. And it has a resistance to the transfer of one charge to the other, so from movement from positive to negative, equivalent to 15 million kilometers of copper wire, so that the charge would have to travel down that distance to go from positive to negative if it was to go through a membrane made out of pure water. Pure water won't freeze either at temperatures as low as minus 40 degrees centigrade, and mostly the water that is important to us is the water which is in our living space, which is the troposphere. Other aspects of water which are important to understand with regard to Viktor's theories are also the so-called anomaly point. Now, this occurs at plus 4 degrees centigrade or 39.2 Fahrenheit, where water is its most dense, had its greatest energy content. And in relation to this temperature of water, there are 2 movements towards and away from the plus 4 degrees centigrade point, which Viktor called a positive and negative temperature gradient. And when the movement of temperature from a higher value, let's say from 20 degrees down to 4, that is a positive temperature gradient because it is a life-enhancing movement. It is a movement in where energy is being concentrated into the 4-degree temperature state. A movement away from that 4 degrees, either upwards or downwards, is a negative temperature gradient. It's one where structure is becoming loosened instead of being, so to speak, consolidated. And this also has a relationship to volume, because at 4 degrees water has its least volume, and at higher temperatures has a greater volume. Another factor also is water's high specific heat, which has one of the highest specific heat, which means that it requires a greater input or extract of heat or cold in order to actually change the temperature of water. And the lowest point of the specific heat of water is at 37.5 degrees centigrade, which is about the same as our blood temperature. And it's this factor of water, this factor that it requires a lot of extra energy or removal of energy, either to heat up or cool down, which allows us to live in many different temperature variations and fluctuations, because our blood temperature doesn't change as a result of that. The structure of water, though, is more inclined to the crystalline, and this is a work which was done by some people studying homeopathy in Germany. And water, in fact, forms what they call temporary nodes of crystallization. So it's closer to being a solid than it is to being a gas. And in water, there are holes in which some consider that memories are retained in those holes. So that water has, this is how, for instance, homeopathy works with water, that the mother tincture or the resonances of the mother tincture are carried within the water molecule. It is really the resonances that are transferred when a medicament, a homeopathic treatment is manifested. It's not the mother tincture anymore. There is quite a work on that carried out by Jacques Benveniste at Paris University. Heat, on the other hand, is always the great harmer of living things. This is just a quick example to show a vibrating plate, metal plate with sand on it, that corresponds to a particular frequency. So those forms, they're Chladni plates, they're called. So those forms there correspond to whatever frequency the plate was vibrated at. But when the plate was touched very gently with a blowtorch, then the whole of the system completely went kaput. So heat, too much heat, of course, is a destroyer, and in particularly in terms of water, because water, as I said before, when the oxygen in water when the water becomes too warm, the oxygen becomes aggressive, and then you start the destructive phases of things. Also, the way of moving water, either centripetally or centrifugally, has an effect on it. It's not so evident from these pictures, but I haven't got any better ones. But centrifugally killed water, as Viktor says, you can see it's all sort of fragmented and broken up into pieces, whereas water which has been moved under centripetal forces becomes vitalized, and it is far more coherent. This also, I suppose, under the magnifying glass would produce something of the same sort of structure we saw in the previous slide. This temperature gradient, though, which is critical to water, and let's see how we can even achieve it in the atmosphere. We're taught when we move up that it gets colder, but you see, it does get colder periodically, and then it gets warmer as we move up. So there is actually a fluctuation, an alternation between heat and cold as we move from the outside of the Earth's atmosphere down towards the center, down towards the Earth's surface. And each of these points, where you go, for instance, from the temperature of minus 90 degrees to plus 10. So here, there are points where you have this 4-degree anomaly point, where water could exist. And in a sense, I'm afraid I won't be able to explain that because I've left the other slides behind. I'm sorry. But in that process, a condenser, what Viktor or Walter would have called a biocondenser, is created, where the energy of the sun is magnified as it gradually approaches the Earth, so that the energy matrix that we live in, where we are, is dense enough to support the life forms which are necessary to be here. Again, this temperature affects and the variation in temperature in water, of course, affects the whole of the climatic situation, because when the temperatures rise, there's too much evaporation, and then we can have flooding and droughts under certain circumstances. And Viktor had two ideas, well, had different ideas about the so-called hydrological cycle, because the normal hydrological cycle is one where the rain falls, it falls onto the ground in the forest, it goes underground, it evaporates from the trees, it evaporates in the ocean, rises to the clouds, fall again as rain. And it also goes underground and charges up the subterranean water table and the aquifers. And the problem today that we have is that this cycle now is no longer the full cycle, but the half cycle. And the half cycle, there's no penetration of groundwater, of rainwater into the ground, because the temperatures are wrong and do not allow it. Now, this comes back slightly to the temperature gradient. You see, if the rain, when it falls onto cold ground, cooler ground. If the ground is cooler than the incident rain, then the rain will be absorbed into the ground. But if the ground is warmer than the incident rain, then it's like dropping water on a hot plate and it skitters off sideways and there's no penetration. So as soon as you start taking the trees away, then you, of course, arrive at a position where there's no water retention, there's also no water penetration through the ground, and there's a rapid re-evaporation because more water is exposed to the sun. And so in the half hydrological cycle, which is really gripping the whole world at the moment, you have a situation where you have flood or drought, or flood or drought, or the result is that the huge agglomerations of water are non-uniformly distributed around the planet, and we get this massive disturbance in the climate. The temperature gradient, again, is very important in the formation of springs. There are two forms of springs shown here. Seepage springs are what we are normally referred to as springs, where water penetrates under positive temperature gradient into the ground, meets an impervious layer, and then flows off according to gravity to wherever it comes out of the side of the hill or wherever it appears. But a true spring, a true mountain spring, is one which can actually arise at the top of a mountain, and it can discharge an enormous volume of water all year round, although there is no catchment area sufficiently large to produce the flow that comes out of it. Now, in Viktor's explanation of this, you have, under a positive gradient, temperature gradient, rainwater infiltrates into the ground, and as it does so, it cools until a body of water is formed in the ground called the groundwater body. The lower formed part of the groundwater body, however, those layers of water, horizons of water, are heated by geothermal heat from down below, and so the water below the groundwater body, the bottom layers, it wants to expand, and that creates an upward pressure. On the other hand, there's a downward pressure from the water lying above the main body of groundwater, until finally in the middle is this 4 degrees centigrade, and at this temperature water is at its most dense and incompressible. So it is actually squeezed between the geothermally expanding water from below and the overburden of rainwater infiltrating from above, and it's squeezed, and the pressure of it will cause it to come out at the top of a mountain. And that is the formation, the reason for the explanation of the formation of true springs. There are other factors here too, in that in the process of infiltration, the oxygen in the rainwater is gradually removed by the plants and the various organisms. And so when you get down to the groundwater proper, there may be virtually no oxygen in it at all. And oxygen is, as I mentioned earlier, the fertilizing force from the sun, a male aspect, whereas the water itself is female. And there comes a point where there's such a hunger of the water for the male oxygen that it is also creates an attraction which draws the water to the surface at the spring on top of the mountain. This can be reproduced, how this actually happens, quite simply. If two bottles are put together, you see when the rainwater infiltrates into the ground, it also pulls all the salts down with it. And so in the process of absorbing and dissolving these salts, it becomes specifically heavier itself. That means that it actually, per unit volume, it is heavier than the equivalent of fresh water. And if you fill the bottom one with fresh water and the top one you put in really a substantial amount of salt, and this capillary tube is inserted before you put the salt water in. Once the salt water has been put in, then fresh water will drop out of the top here, actually above the surface of the salt water. And so that explains quite simply how the spring occurs at the top of mountains. And this is where we come now a bit more to discuss the temperature gradient, because the temperature gradient is absolutely vital for fertility. Under positive temperature gradient, that means that the air is warmer than the ground, or the rainwater temperature is warmer than the ground, that the rainwater will infiltrate. And as it does so, it takes all the salts down to just above the main groundwater body, the 4 degrees centigrade part, where the salts are precipitated out. Because Viktor says that under darkness and the exclusion of light and the exclusion of heat, precipitation occurs with cooling, so that the colder the water gets, once it gets to its most dense condition, it has no room for these other elements in it, and it chucks them out, and so they sit just above it. When you cut down an area of forest, though, then a certain amount of the ground gets warmer, so that the rain falling on it then doesn't penetrate. The result of this is that there is less of an overburden of water above the groundwater body, to counteract the geothermal pressure from below. So that part of the water table gets shoved up under the place where the forest has been removed, and brings up the salts with it. Now, in an extreme condition, as occurs here, then the salts all come to the surface, and you have serious problems of salination. So if that's why it's very important that there should always be a good balance of forest and open space. And even in all agriculture, certainly. And the effective also of forest and belts of trees is to contain the carbon dioxide, which is, after all, which is transformed into growth through photosynthesis. If the carbon dioxide is not there, it is swept away because there are not enough trees, then the growth that occurs is not as high quality. There are situations, however, where there has been massive deforestation, and the only way to return the river to its normal healthy state and to bring the groundwater back to recharge the groundwater is to plant trees on each side of the river, because then the river will become cool, but also the ground temperatures around the river will become even cooler. And as heat always moves to cold, whatever water is in here will be sucked into the surrounding soil, and in the process will take all the salts shown sort of dotted here away from the surface, which will enable other trees and other life to develop. It also will bring the groundwater up, will also be recharged. But this is very critical in terms of what we are doing with rivers, because here again we have a situation where the ground is cool, but it's cooler than the river, so the river acts as the nutrient transport from its source all the way along its length, and as it moves around bends and so on, and we'll discuss it a little later, it grinds up gravel, it grinds up the various rocks in its bed, and these it then dissolves, and it enriches itself with nutrients. And a condition where of a positive temperature gradient, the water of the river will then flow into the surrounding soil and revitalize it or recharge it with minerals, and also the groundwater table. On the other hand, though, if the trees have been removed and the water then becomes cooler than the ground, because ground without water in it heats up much more rapidly than ground with it, then whatever moisture and nutrients are in the ground get sucked into the river, and so the ground becomes impoverished because the trees have been taken away. A different situation occurs when, for instance, you have a shaded side of a river and a cleared side of the river. On the shaded side, the profile then becomes asymmetrical because the water is cooler on the shaded side. It has a greater ability to shift gravel and sediment. But on this side, the temperatures will be cooler than the water, on this side hotter. So in this situation, the river actually acts to transfer the nutrients from one side of the river to the other one. Now, water in its natural flow always wants to move in curves, in sinusoidal forms, to sway backwards and forwards. And even these are two diagrams taken from a book of hydraulics, where the water was put in a straight channel and some sand put in. And even in this, so to speak, straight jacket for the water, which likes to move, these meanders were formed. And so that was the natural way that water likes to flow. But the flow of water is governed by temperature, and very, very subtle differences in temperature. Presently, the differences in temperature, which may be as little as 1.5 degrees, are considered so insignificant in conventional hydraulic engineering and river engineering that they're totally discounted. But it's precisely these temperatures which are important, and they determine whether a river will pick up sediment, transport it, and deposit it, and whether in fact the river is going to flood or not flood. Now, as was mentioned a long time ago, relatively speaking, every particle of water is associated with a certain temperature and a specific velocity. And here you can see at the top the velocity curve of water. The cooler the water, the faster it flows, and the longer it flows over a given time interval. So all these different lengths of arrow represent waters at different temperatures and the distance they have all flowed in the same time. And from this you get what is called a velocity curve. Now, once each particle of water in these various skeins or horizons of water has exceeded its critical velocity relative to its temperature, then turbulence occurs, so to speak, and it causes spirals to rise from the bottom upwards. And that is why when you see in rivers, many of the ripples break backwards, because the water has exceeded its the velocity according to its temperature. But these are valuable things because they break the water's flow, they stop it from going too fast, and they also act to distribute nutrients to the right and left of the watercourse. But what happens in rivers is there's a series of temperature gradients where they alternate from positive to negative. Now, under normal situation here, this shows how this alternation occurs. Under negative temperature gradient, whatever is carried by the river is gradually deposited until the maximum point is reached here, which creates an overfall. Now, at the overfall, the water falls over and a horizontal vortex is created. And in the middle of this vortex, the water is identifiably cooler, because water cannot move into a vortex without automatically cooling at the same time, because the densest water always resides in the middle of the vortex. So at this point then, instead of a negative temperature gradient, we have a positive temperature gradient, because the water is now in a cooling direction and not in a heating direction. And as a result, it's able to pick up more sediment, grind it and scour it, and transport it. And gradually, as it moves, it transports sediment, and then it gradually turns over to a negative temperature gradient. It becomes warmer due to the sun, due to sort of frictional forces, and it drops its sediment again. So you have this sequence of positive, negative, all the way down a watercourse. But if you disturb them, because you could, for instance, the river was flowing through natural forests and you take the forest away, then suddenly you have a succession of negative temperature gradients, which means that everything is dropped all the time. There's no carriage there's no deepening of the bed, there's no transport of material, and so you have a flooding situation. And I think probably this has been happening in the state of Washington recently for the same sort of reasons. Viktor also, in his, he developed a system of making water flow in this vertical manner, longitudinal vortices in pipes, because most of the pipes that we have for use in water mains and so on are just straight pipes. They're cylindrical pipes, they've got nothing in them. Viktor installed these veins, like sort of fluted veins like this, which the function of which was to cause the water to turn into a vortex inside, and in that way, again, firstly the vortex is this energizing process, it's also a cooling process, and it enabled the water to pass through the pipe much faster. A better pipe, in fact, was another patent he did, which is virtually the same. It's not quite the same vortex-creating device, but the pipe was wooden because it was very important that water should breathe. In a steel pipe or an aluminium pipe or a plastic pipe, water cannot breathe, and being a living substance needs to be able to breathe all the time and interact with the environment, otherwise it dies. And most of the water reticulation systems we have today, what is being delivered is dead water. And it's always disinfected with chlorine in order that, theoretically, no harm is done to the people who drink it. But the thing is that blood is also about 90% water. And so when you drink chlorinated water, then you are also chlorinating the blood. And you are also disinfecting the blood, which is why people are becoming more disease-prone, because they're drinking so much chlorinated water. They also absorb it through the skin in showers and so on. So this was a way, in fact, of transporting water, and it used to be the way. In New York they had wooden water mains, and in many cities they had wooden water mains. But according to Viktor's investigations, once they started using cast iron or cast iron with tar linings and things like that, then the incidence of cancer went up hugely as a result of it. He was able to track it. Everywhere they put a new suburb with a new water main, and the cancer followed it all the way along, because you are actually putting the body in a very debilitated state by drinking this chlorinated water. And what happened in this wooden pipe was the formation of this longitudinal vortex. And this is actually the double movement. Firstly, the central one was, of course, the coldest. But as it flowed along this path, it created these sort of toroidal things. They're only shown as toroidal rotations in the opposite direction, a bit like ball bearings, but the effect of these is to reduce the friction on the pipe. It also, the process, I'll show you the next drawing, which makes it a bit clearer. So this time you're looking down the pipe, and it's actually a very complicated movement to try to describe, because the flukes, the guide veins, which start the water to curl over, make it curl around the outside like this, but they induce a movement in this direction of the central core water. Now the central core water is where it's coldest, which moves fastest. This other water acts in a sort of ball-bearing function around the outside. What happens is that due to centrifugal force, the oxygen is propelled towards the outside because it is a heavier element, and also all the bacteria which are residing in the water when the water first is introduced into the pipe. And so some of the bacteria require a certain amount of oxygen to function. Other ones, if there's too much oxygen, they just burn out, pathogenic ones. And so the effect of this is to remove the pathogenic bacteria, build up the life-enhancing bacteria, and build up the energies, the immaterial energies in the pipe itself. So by the time you have got to the point of delivery, the water has already been vastly improved by passing through the pipe in this condition. It would also transport ore and various other things straight down the middle without touching the sides. But this same longitudinal vortex is important in streams and in rivers, because it is through their alternation that firstly the bends in the rivers are created. It's also through the vortices, the longitudinal vortices especially, that the rocks are ground up, the sediment is ground up and delivered to the environment. The coldest water filaments always being near the center. And Viktor described what he called his energy cannon, which was the way in which the alternating of vortices created the energies and how they were finally delivered to the environment. Now, there's sort of anti-clockwise energies and clockwise energies, positive, negative, always the interaction between the two. So on a left-hand bend, then the movement is anti-clockwise, and the right-hand bend, the longitudinal vortex, where it's clockwise. But there's a point where they switch from one to the other, where anti-clockwise becomes clockwise, clockwise becomes anti-clockwise. And that is where the energies which have been accumulated by the vortical motion, where the minerals and trace elements are accumulated and suspended in the water because the grinding action takes place here at the bends, are then dropped at the ford, where the ford is, where it flattens out, because that's where the movement of one vortical movement transforms to the other one. And this is what Viktor called his energy cannon. This is where not only were the physical substances, the nutrients deposited, but also the immaterial energies which had been gathered and created during the vortical movement, and they were discharged into the environment at that point. Now, if you had two bends going in the same direction, he said it was very important that a river will always do this alternation, but you shouldn't put two left-hand bends where there should be a right-hand bend, and so on. And that is not understood in river engineering because that disturbs this whole process. How a bend actually forms is again due to the differences in water temperature and density. That if, for instance, up here we have water which is flowing through a forest and it's all shaded, then a profile evolves which is more or less symmetrical because the coldest water is in the center and there's no other heating influences. But once you come to a point here, for instance, where the forest on this side has been taken away, and so this soil here is hotter, and then you get an asymmetrical profile because the densest water is now on the far side and the hotter water is this side, and because the water is denser, it flows past the warmer water, the colder water flows past the warmer water and curls around it, and so gradually that, in the process, that is how the bends in rivers evolve. Eventually you get sort of double profile here, which is somewhere around the ford where the energies change over from one to the other. But in many rivers these energies have been completely depleted, and they have to be reformed because, coming back to the previous mention of energies and how the energy is primary and the form secondary, if you want to recreate an energetic river, you have to tackle the energies within the river and not the bank. But you can do it by the bank, but very carefully. Most bank confining structures are just straight concrete walls to stop the water from going out here or there, but that doesn't do anything to restructure the actual energy of the water so that it can flow naturally. Now, these were inventions of his which generate vortices down the middle. Some of them will cause the water to rotate this way. It flows from the bed up this guide vein, I suppose, and flips over, and then it starts a vortex this way. Or on the other bend, it would then cause the water to rotate in the opposite direction. So it would artificially regenerate the vortices or the energy path within the water itself. There are other ways to do it. Also, that you can put what he called energy bodies in the river. That would mean tethering some sort of egg shape. It may not specifically be this egg shape, may be a longer one. But in the water which has become moribund and dead, you put the egg in it, and then it starts a vertical motion behind the egg. So you could, in a straight stretch of river, or somewhere where you would want to remove sediment and where, you know, that's and you wanted to cool the water, then you could put such a device in. And a further factor, of course, which affects rivers, but it's a very subtle one and not really as realized as much that it does have an effect, is the actual rotation of the earth and the direction of flow of the river. Because let's say, for instance, we have a river which is flowing from west to east. So that means the river is flowing towards the sun. That means that a little packet of water in that river is also moving towards the sun, and the sun is coming the other way. So as this movement occurs, that packet of water does not heat up nearly as much as it would as if the river was flowing from east to west, where the packet of water would be flowing underneath the sun all the time and getting hot. Do you understand what I mean? So generally speaking, therefore, west-east flowing rivers tend to be more fertile on both banks because the water is maintained at a very marginally cooler temperature, and therefore is able to transport nutrients. At the bends, it's able to grind up nutrients. So right from west to east, it will be fertile on both banks. When the river flows from east to west, however, because each water packet gets heated up more quickly, then the ability for the river to carry sediment diminishes, and the sediment is dropped. That means not only is the sediment dropped, but the nutriment is dropped. And so that at the end of the river, the banks tend to be barren because there's no more substance in the water. On the other hand, you can have north and south flowing rivers. They tend to be asymmetrical because the water, if the earth is turning this way and this is where the river is, then the water tends to bank up against the movement of the earth, so due to inertia. And so the rivers tend to be asymmetrical, with the deepest part on the western bank. And so what happens here is a situation rather similar to the one where you get to transfer, the river acts to transfer nutrients from one side to the other. And in north and south flowing rivers, one bank tends to be more barren or less fertile than the other. And if they flow into northern seas, then they produce half development, because as they flow further north, the water cools and is able to carry and transport more material. On the other hand, if they're in southern latitudes, then they end up being like the Nile. The water gets hotter and hotter, and they finally form a delta because everything is dropped before it goes into the sea. Okay, now this just to show you what happens under what can happen under river regulations as they're carried out today. The outline here, this green outline and blue outline, is the original form of the Rhine, how it chose to flow in that particular situation. It may have begun to flood because, of course, the forest would have been cut down, although Germany hasn't cut down nearly as much forest as other people have. And maybe it was some way it became inconvenient, or perhaps it was not navigable, and they wanted to use it as a waterway for transport. At any rate, this was installed instead, which is a canal of constant width and constant profile. And suddenly what had been a live thing became constrained in this terrible straitjacket, which didn't allow it to move, and the energies gradually die in it. And so this river has constantly to be dredged. It's not a river anymore, it's a sewer, finally, because instead of the sparkling water that the Rhine used to have, you know, the Rheingold was what people spoke of, and that was the Rheingold was because rocks rubbed together of a certain composition on the bottom due to the coldness of the water and the natural flow, producing a glow which is known as triboluminescence, a goldish glow. So people used to see at night glowing along the bottom of the Rhine, and that was the Rheingold. Well, there's no way you can see that today, because it's a grey-green, muddy, slimy, inert brew, and that has already been caused by the shoving it into a canal of constant width. I think one last thing needs to be said about water, and this is only very, very brief, and that is that probably the best containers for putting water in, if you want to store it, are either egg or amphora shapes, because the egg, again, is a form specifically chosen by nature for the maintenance or continence of life. She didn't choose cubes, didn't choose spheres, didn't choose any rectangular shapes, and water contained in this terracotta vessel would maintain its vitality for a very long time. Firstly, it's cut out from light, so that no light gets to water. The light is, the sun and heat are the great dangers for water. And if the porosity of the material is correct, then for each 600th part of the contents that evaporates, the contents will be cooled by 1 degree centigrade. So that if this started out at 20 degrees centigrade, it very quickly would come down to a very cool temperature. And not only that, but the water inside it would, because of cooling on the outside, it would descend in a spiral on the outside, moving the central water up, and so there would be continuous circulation. And that in such a shape as this, there are no dead corners, no stagnant corners, which there are in cylindrical containers and so on, where there's no movement. And of course, once there's stagnation, then bacteria and all other sorts of things can develop. Now, of course, apart from water, which is fundamental to all life, without the forest, there's also no life for us, because the forest controls the climate, it controls the distribution of water vapor in the air, it also enhances fertility because it keeps the groundwater table up. There's many things that the forest does. It tempers everything for us. So without forests, in fact, we have no future, which is why I put this up. And this is one of the things that I think has to be pointed out, that while it is very important that all sorts of devices should be designed and produced to create free energy or as cheap energy and as environmentally sustainable energy as possible. The bottom line is there has to be some greenery out there, because if there's no greenery out there, there's no oxygen and there's no life and there's no rainfall. Because everywhere we've seen that the forest has disappeared, then the drought has moved in. So it is of fundamental importance for us that we should plant more trees as fast as possible. And in fact, one almost might say that all the unemployed people who are unemployed at the moment, of which there are vast numbers in most of the so-called civilized countries, they could quite easily put their hand to reforestation if it was done organized properly. But what we really need to find out too is what value do trees have for us? This is an evaluation of a 100-year-old tree by Viktor Schauberger and what it actually has done during its 100 years of life. And during this period, it has photochemically converted 9,100 kilograms of carbon dioxide and 3,000 liters of water. And it's stored about 23 million kilogram calories which are equivalent to 3,500 kilograms of pit coal. And it has made available for the respiration of man and beast 6,600 kilograms of oxygen, so that in its 100 years life, this tree has produced 6.6 tons of oxygen. In addition, it has evaporated into the atmosphere at least 2,500 tons of water, and has supplied a member of the Consumer Society with oxygen for 20 years. So, in view of this marvelous production of trees, which it does with giving, there are no unions involved in trees. They give all the time, and their giving is unconditional. And this is something maybe we should also think about ourselves, because in order for evolution to proceed, the giving must be in greater measure than the taking. Because if everything is taking, then finally the pot is empty. It can only succeed if the pot is continually being refilled or being filled up more and more. Basically, there are 7 types of tree, and they are determined according to whether they're light demanding or they're shade demanding, whether they're hardwoods or whether they're softwoods, whether they're coniferous, deciduous, or they are a rainforest tree. Now, as far as light demanding timbers are concerned, they mostly have a thick bark, whereas shade demanding timbers have a thin bark. Hardwoods can be either thick or thin bark, as can be softwoods. Now, a tree, again coming back to the origins of energy, the energetic basis for all things, a tree is a mirror of the quality of light that falls upon it, a quality of the energy in its environment. So that in a situation where the tree is exposed to hard light, which is blue light or ultraviolet light, the wood is soft. And where the light is soft, which is red light or infrared light, where those frequencies of light predominate, then the wood is hard. So the tree is a mirror of the quality of light. If the light is hard, the wood is soft. If the light is soft, the wood is hard. And of course, there are all sorts of graduations in between. And even the shape of the tree is affected to a certain extent by its location in altitude, because the lower the altitude, the greater the preponderance of infrared and red light, and the higher the altitude, the greater the preponderance of blue and ultraviolet. Again, there's this levitational energy spiral which moves upwards against the forces of gravity, which is why the tree also grows upwards, why we stand upwards, why everything knows which way up it's supposed to be. And in an isolated environment, then the tree near the equator tends to spread laterally, because this movement of energy is not very strong going upwards. As we get to higher latitudes or higher altitudes, then the energy, upward energy, increases, and it's reflected partly in the form of the tree. So that high altitude trees tend to be rather more pointed than very low altitude, low latitude trees. What is important, but particularly important in reforestation, is and in trees generally, is to understand what is a shade-demanding tree and what is a light-demanding tree, because doesn't seem to have been taken into account in forestry, in modern forestry. This is a photograph taken on my property in Australia shortly after I cleared some land around these two trees. This area under here was covered with a very dense undergrowth, lantana it's called, which goes wild in Australia. And so these two trees, which are these two trees here, grew up with the bottom part of their trunks protected from light. About 4 weeks or 2 weeks or so, somewhere in that sort of period, I noticed that one of the trees was growing some branches on the lower part of its trunk, and the other one was not. And I've been looking at this because I had also been studying this been involved with Viktor Schauberger's concepts for quite some time. But this tree is a shade-demanding tree because it's put out branches to protect the trunk from sunlight. The other tree is a light-demanding tree. It has a much coarser bark, and it didn't put any branches on. Now, why did the tree put branches on? What was the necessity for a shade-demanding tree to add branches to itself? Well, what is very critical for a tree and for the health of the tree is the movement of sap and the tree's internal temperatures. So that when the sun impinges on thin bark, of course there's no insulation or virtually no insulation, and the temperatures within the tree start to rise, and this causes a dislocation in the natural movement of the sap. So in order to protect itself, the tree immediately puts branches on the outside against the sun. So while we tend to think that trees and shrubs put out their branches to catch the light, they do so, in fact, to protect themselves, their center part of the tree, from light, because otherwise all their metabolism gets upset. Now, this is very, very serious when it comes to large-scale reforestation and large-scale planting. Just to show you how this, this effect also happens, here, this is, again, a profusion of small branches. This tree was suffered from a forest fire, and so all the way up every branch, as far as possible, there were little shoots brought out, because in the fire all the outside skin of the tree had been turned black, which absorbed all radiation and all heat. So if the tree was to survive at all, it was absolutely imperative that this blackness should be protected by a color which is natural to the tree and would normally reflect the sunlight. Again, by overexposure to light demanders, when they're overexposed to light, they produce some peculiar characteristics. This is a small beech tree growing at the side of a forest, and normally most of the development of a beech tree is up in the crown, but there are myriads of little branches down below which make the wood very knotty. Again, because of the disturbance in the sap flow, this is another shade-demanding tree, and you can see that the trunk is actually conical, and that is because, due to the heating processes within the trunk, all the nutrients are deposited sooner than they should be, which adds to the girth of the trunk. Whereas that same tree in its natural state would have a virtually cylindrical trunk, and all the development would be at the top. This tree here has been exposed to electromagnetic radiation in the form of radar and microwave activity, which has created a distorted form of the tree. You can see how chaotic it looks. According to the German engineer Dr. Wolfgang Volkert, microwave senders, which are these communication senders, act in the same way as microwave ovens, and any living thing exposed to them gets cooked virtually from the inside out, because he noticed that in Germany, when a new tower was put up, and he made a study of it, on all the slopes of the hills and mountains facing the tower, the trees began to die off, and on the opposing face, on the shadow side, as it were, they were still okay. And one of the reasons for this is that one of the wavelengths that they use for microwave transmissions is 21 centimeters, which is the natural harmonic wavelength of hydrogen. And so the hydrogen atom within the water molecule becomes excited and disturbed, and perhaps even removed from the water molecule, which then, of course, upsets the whole of the sap flow and everything else. But it would also upset anybody else who happened to live there. If trees can't move, they're rooted to the ground. Human beings and animals can. But I would imagine that because of this, that anyone living under the path of one of these microwave senders would be more susceptible to disease than someone without. That was a slight digression. I would want to continue with the effect of light and understanding it on trees. Here there's another tree with the branches all on one side. And again, from our conventional point of view, we'd said, oh, well, he's got the branches here because that's where the sun is, and it's putting it out to catch the light. There are no branches on the other side because there's no sun. In effect, that is true. But the proper interpretation, or at least Viktor Schauberger's interpretation, is that the tree put branches out in order to protect itself from the sun. No branches would go on the other side because it didn't have to protect itself from the sun, which is exactly the opposite way of looking at things. Viktor Schauberger often said that if you want to know the truth of how something should be done, find out what today's technology is doing and do exactly the opposite, which means really a 180-degree change in our point of view. Here, another tree, this is a tall pine tree. You can see there's a lot of branches all the way up and down the trunk. It must have been left perhaps as a mother tree in order to provide more seed. But when its neighboring trees had been cut down, then it had the necessity to grow all these branches up and down the trunk on the outside in order once more to restore its inner temperature conditions, crucial to it. These again, oh, that's the same one as before. Again, here's another tree. The lower branches have been cut off, and then suddenly you get a profusion of branches growing on it again. Same reasons. And when you compare the girths of naturally grown and artificially grown plantation timber. Now, this is a fir, a shade-demanding fir, the big one, and as a result of overexposure to light, then all the annual rings have been spaced apart, the wood is spongy, the whole metabolism of the tree has been upset, and so you get huge growth. You get quantity at the expense of quality. There's no quality in this, and most of this wood would be unsuitable for any structural purposes. Whereas these other trees here, also fir, are the same age as far as can be seen, because their annual rings are so close together they're almost indiscernible. So these are the two differences. This is very high quality wood, and this is very low quality wood, and this sort of wood is what is being produced in most of the plantation forests and so-called reforestation projects. Because in all reforestation projects, it should be important, it should be obligatory to plant as many different species as you can instead of a single species. Otherwise you arrive at a monoculture. And once you have a monoculture, you introduce into a natural setting what used to be a cooperative process into a competitive process, because all the trees in the monoculture have to draw their nutrients from the same horizon. They're all the same species of tree, they've got the same root patterns, they take the same amount of moisture, they take the same energy from the sun, they reflect the same light frequencies, and so there's a total wastage of energy at the same time as the tree is also trying to take from its neighbors whatever it needs to survive. How this, the effect of heat on the growth of the tree is more apparent in this diagram, where on the shadow side of the trunk, so to speak, then the annual rings tend to be close together, the sap waves are finer, the movement of sap up and down the tree on that side faster, whereas on the other side of the tree, which is exposed to sunlight, then the annual rings become wider, the material between them pithier, and the movement of sap slower, and under normal conditions a lot more branches would grow out from that side, making the timber virtually useless because there would be too many knots in it. And when sap moves up and down the trees, in a healthy tree, and a shade-demanding tree in this instance, in this proper environment, then there are virtually no branches which are produced on the trunk. The trunk is virtually cylindrical, and because there are no branches, there are no impediment to the movement of sap going up the tree. So it can rise to the top of the tree, which could be 150 to 200 feet high. And the sap waves are very small, the sap ducts are very small. And now, how does the sap get up there? Because, of course, under normal suction, you can't raise water up more than about 9.8 meters by suction. And osmosis won't take you that much further either. So how does the sap actually get up there? Now, according to Viktor Schauberger, as the day warms up, or as the climate warms up, the season warms up, there's a general rise in temperature. And all the carbonic acid, which is in the sap, which is in the water, gradually warms, and a certain portion of it then turns into carbon dioxide, which is a gas. And these bubbles of gas then fill and block off the sap ducts, and like corks, they rise and they push the sap and the water ahead of them right to the top of the tree. And at night, when it cools slightly, they fall down, and then they draw in all the sugars and starches and the nutrients and the gases which have been formed during photosynthesis during the day. So that's what happens when you have a naturally grown tree with very tightly spaced annual rings. When it is a plantation tree, then the rings are wider apart, there are more branches, but also the sap ducts are commensurately wider apart. But the bubbles of carbon dioxide are not sufficiently, they don't expand to fill these ducts in the same way as they expand to fill these ones. And so the sap is not lifted, the nutrients are not lifted as high as they would be in a healthy tree, and therefore they're deposited at the base, which is why these trees then are more cone-shaped at the bottom. Instead of being straight, then they have this shape, which of course everybody thinks is ideal for a Christmas tree, very picturesque, but actually a Christmas tree like that is a very unhealthy tree. Trees have a function. Not only do they give us oxygen, but they also have a symbiotic interaction with trees, in that they provide for us the color we need most for rest and peace of mind, which is the color green. Because trees absorb light by and large in the ultraviolet, violet part of the spectrum, and the infrared and the red part of the spectrum, but they do not absorb light in the green part of the spectrum, so that is what is not absorbed is reflected. We, on the other hand, are not very sensitive to ultraviolet or infrared, but we are very sensitive to green. And green is the color that the trees give us, and if there's a lack of greenery, then I think it has quite an effect on the psychology of the people who are living in such an environment. In many modern cities, there are very few trees, and I think this must lead to an increased violence, a fundamental rising of the disturbances in the nervous system. And also, of course, then there's a lack of oxygen, which produces anoxia and various other things. Trees can also be likened, in Viktor Schauberger's, to biomagnets rather than magnets. A magnet we usually view as being a bar magnet, which has a north pole and a south pole, and the magnetic lines of force go from the south to the north, and they spread out across the middle. And that is generally what our view of a magnet is. However, a tree has a completely different form of being a magnet. This is one which is based on a hyperbolic cone. Again, this is actually a bit cone-shaped in form, but if you can see the way the forces arise inside this tree, that there is, this is an experiment I carried out, so I measured exactly where all these filings are moving to, and out of the top they flow, out of the top they flow in towards the sides, and they flow in from the bottom. So in a sense you can get a picture of what, this form, the hyperbolic cone, is again to do with non-Euclidean geometry, which is the geometry of nature. And so you can see that a cone taken in this shape seems to already give the pattern for the growth of the tree, because all the filings on this are disposed gives a very tree-like form. If we come back to, if we were to view these as the annual rings on a tree, water, as I think I mentioned when we were talking more about water, has a dielectric value. It has a very high dielectric value, which means it's able to resist the transfer of charges from one side to the other of it. If in the tree we have the green part is water, which eventually then becomes the annual ring. Then on each side we have positive and negative charges. As the surface area of the outside blue cylinder is larger than that of the inside red one, then the density of charge, the intensity of the charge on the inside one is greater than it is on the outside one. And as a tree is made up of a series of concentric rings, then the charge from the outside increases as we move towards the inside. But under certain conditions, the energy of the tree can be severely disturbed because of the distance and the spacing between it. Now, when we're looking at the terms of separated charges of positive and negative, the closer the charges are together, the greater the potential. In that sense, the greater the life force. The further the charges are separated apart, the lower it is. Now, here we have a 33-year-old tree, a section through the trunk, and you can see straight off that this was a plantation tree because the annual rings in the middle are very widely spaced apart. That means that when the tree was a young, struggling little tree, a sapling, it was exposed to far too much sunlight. And so its girth widened at the base, and gradually, as its neighboring trees grew up, then it became more and more protected from the sun, and the annual rings got closer and closer together. At 26 years old, someone came and cut down all the trees around the outside of it, and at once, all the annual rings then expanded. Now, the time that this tree was actually healthy, it was in this part of its life. Whereas here it was unhealthy, and in the center it was unhealthy. And in terms of the life force, the potential, so to speak, between here and there, the life force would have been much less because the charges of positive and negative were separated by much greater distances. Here, they would have been very close together, and so the two charges would have been closer together and the potential much greater. And so this graph at the bottom here, the blue one, shows you really what the potential levels are, their nominal values, as you move from the outside to the inside. So from here to here, there's virtually nothing. Suddenly they peak because they get very close together. It falls off, and then from there to there's nothing again. On the other hand, the actual generation of a charge from the outside to the inside does increase constantly. It's difficult I have to differentiate between potential and charge. Potential is the life force. It's a different energy from the electrical charge, which can be measured from the outside towards the inside. Viktor Schauberger made some probes, and he probed one probe very deeply into the center of the tree and the other one on the outside. And in that way, he was able to make light bulbs light up. I'm not sure whether I haven't mentioned that already, but that is the process. Why does growth occur at the extremities of the tree? Why is there not more growth down the center? Well, if we look at this tree as a system of energy pathways in all the little tubules and sap ducts and so on, when you get to the top of the tree, then these are all very close together, which means that they're minute in size. And in a sense, also, there has been a tremendous increase in the potential in the life energy of the tree at that point, so that what is passing up these very small sap ducts are only the very finest materials, the sort of homeopathic substances, which, because they have been potentiated, create the greatest energies for the tree to grow, whereas down here at the bottom, this doesn't occur in the same measure. Very important too in our understanding of the interaction of trees is also the root structures, because we can create an enormous amount of harm by pulling out a species of tree which may have a certain root structure which helps the whole balance of the forest. And although these aren't trees, I'm going to put these on one after the other in order. Here you would see a very simple plant, which perhaps was the original plant which grew in this place, maybe a sort of primordial plant. In the process of growing, it made a little bit of shade on the surface. It created coolness below the surface. It trapped a few particles from the wind, and that allowed another plant to develop but this other plant had roots which came in a different area. They didn't actually compete so much with this one. It had a different root shape, and it was more broad spread, and it again created more cooling. That means that the depth of moisture would increase. More particles were trapped by the wind, which then would allow another plant to come and take root, which had a deeper root system. And that in turn multiplies more complexity, better ground cover, and another plant with a different root system would come in, would grow, and this would give way to the possibility of yet another one to come, and so on. So all these plants gradually, these are all real plants, mind you. These are not just drawings. There's someone actually measured all these actual plants. So by the time you get, you get a significant complexity of roots. But if this one, the last one I put on, was the major one, which was the major species, which happened to be very good for making furniture with, so everybody took it out. Then when I take it away, suddenly, where's the water going to come from? Because this plant was actually going down and getting the water and bringing nutrients up for the other plants. So it's very important that always there's as many varieties of plants and trees as you can have in a normal forest. These are more or less the same roots that I showed you before, but that is their relative distances. This is 4 meters below the surface, and the other ones are there. These are actual plants, and it shows what and this is only a few, because the book that I have has got about 260 different root systems like this. So when you understand this complexity, this huge Gordian knot which is occurring underneath the ground, then it begins, you understand why it is so important to have all the diversity, because it's the diversity which allows all the plants to take from different areas, to take minerals, and they don't compete with each other as they would in a monoculture situation. Okay, now we're going to dip lightly into the mathematics of all this, which have largely been determined and formulated by Viktor Schauberger. Viktor Schauberger was a physicist and a mathematician, and when his father died, he agreed, or he promised his father that he would try and develop a system of physics and mathematics which would explain Viktor's theories in a way which was irrefutable, so that it could never again be said that Viktor Schauberger's machines didn't work or that his theories were invalid. And it was this task which Walter set himself upon the death of his father in 1958, at the time when they came back from the United States. Viktor Schauberger's mathematical system is based on the harmonics of the monochord. This is an instrument which was used by the Pythagoreans in order to determine harmonic intervals on a resonating string. And these intervals can only be determined or only positioned at whole numbered divisions of the string, so that if you divide an open string 1 into a half, then you get the first octave. So just to the right and the left of this point, half position, you will not get a state of resonance. It only comes when you have done it exactly on the point divided by, where you've divided the string by 2. The same occurs when you divide it exactly on the point dividing the string by 3, in which case you get a sort of tripartite waveform which moves between the nodes of where the string is divided. When you divide it by 4, then of course you get the second octave. And so that any string of whatever kind would produce at once a series of overtones, which are the overtone series which rises from above them, and also in the same sense a series of undertones. And Pythagoras and the Pythagoreans made a study of these because it was important to determine the harmonics of things, because they saw the world as being the manifestation of qualities and harmonics or harmonies. And in fact, the student had to study or play, pluck upon a monochord for maybe a year or 2 years until he could hear 120 harmonics on the string. Now that means the harmonics were going to an extremely high level. This was then important in order to realize how, just before I continue that, actually, just to show you how this links up with the hyperbola we saw before. If I can put that to the side and put this on here, then you will remember. Then you can see that the full length of the string is 1, which is from here to here. The half is there, and the third is there, and fourth is there. So that in fact this whole hyperbola, it represents the division of a string into an infinite number of integral divisions, i.e. dividing by a whole number. And as it's infinite, so at the top of it, the quality, in the sense of quantity times quality, the quality is infinitely high, as is the vibration at the top. And this gives us some idea of how higher qualities and higher energies and higher vibrations become the controlling force, because if we take, for instance, these vibrations at the bottom, we'll say they're 1, 2, 3 cycles per second, or 2, 3, 4, 6 cycles per second. In order to be able to resonate with more and more, and to be in harmony with more and more things, we have to raise our vibration so that what is the next higher vibration is in tune with all of these. So if we take the next higher vibration, for instance, as being these green ones, then the vibration of 30 cycles per second is directly harmonic with 2, 3, 5, 6, 10, and 15, all of which numbers will divide equally into 30. Or 12 would be 2, 3, 4, and 6, or 10 would be 2, 4, 40 would be 2, 4, 5, 8, and 10, and 20. But again, once again, these, in order to combine them into a harmonic whole, they need to be, again, associated to a higher number even than themselves. So a number 120 would be a number in which to all these various numbers, 1, 6, 10, 12, 15, 20, 13, 40, are all can all divide into equally. So that we come back to what I said earlier on about energy, about the higher energies being the formative energies. And when we look at this vibrating plate, we can see again how vibration creates a particular form. Here is a square plate with sand just sprinkled over it. The vibration is started, and gradually the final form arises. And when that vibration is doubled, or when the next octave happens, then, as is shown in here, which is a different pattern, then the pattern becomes more complex. So here we have the first, what you might call the bass tone. There is the first octave, there is the second octave, and there is the fourth octave. Again, the complexity increases as the vibration rises, but the form still has the same fundamental characteristics. And it seems to me that all physical manifestation is based on states of resonance, and these are very critical and they're very precise. As we saw with those sand plates, a particular frequency produces a particular phenomenon. And therefore, if we want to arrive at phenomena, or if we want to recreate phenomena, then we need to arrive at those frequencies which are conducive to its formation. Unfortunately, the way most large numbers are handled, and here we are dealing with large numbers, is done using scientific notation, where a number is written as, let's say, 2.5 times 10 to the power of 26 or something like that, which means that it's the number 2 and then the number 5 and 25 zeros coming after it. And if you were trying to seek a particular level of resonance, you would need to know exactly what the last digit of all those 26 digits after the decimal place were. And this is what gets lost out. This is what we lose with scientific notation. On the other hand, with computers today, there should be no problem in determining a frequency value up to the 20th and 32nd place of decimals in order to find precisely that frequency which would from which a particular form could evolve. Interestingly enough, also, that if we're looking at resonance, then this is... wait a minute, because I want to sit there. These are some figures that it just came to me slowly as I was doing all my research, and it seems that the number 29 or 2.9 or various forms of it seem to have a peculiar coincidence with planetary phenomena. The speed of light is 299.7 kilometers per second. The Earth's natural resonant frequency is 29.97. The mean diameter of the Earth's orbit is 299.1 million kilometers. The Earth's mean orbital velocity is 29.79 kilometers per second. The length of the lunar or synodic month is 29.5 days. Saturn's orbital period is 29.46 years, and so on and so on. So the number 29 seems very strange number and associated with the Earth. We discussed earlier also the geometries, and this actually puts them more under the limelight because this section we're actually dealing with the mathematics. Now, this compares the two geometries, the non-Euclidean and the Euclidean. Nicht-Euklidisch is non-Euclidean, Euklidisch is the Euclidean system. Here we have the circle, the straight line, the point, the radius. And here these shapes are these ovals or these ellipses are taken as sections through a cylinder, taken through a right-angled cone, which means a cone where the shape is actually a right angle and it's circular this way. Any inclined section through a cone will also produce an ellipse. So all these are the elements of our technical world. So the circle, the straight line, and point are all part of the same element, in fact. The circle has a certain radius. If I reduce the radius to 0, then the curvature is infinite and I have the condition of the point. If I increase the radius to infinity, then I have a position where the curvature is 0 and I have the straight line. So the straight line, the circle, and the point are all aspects of the one element of the circle. But the circle and the straight line and point do not exist anywhere in the physical universe. They are of the mind. They are transcendental. They belong to the realm of measurement between things. They belong to the realm of thought, excuse me, but they do not belong to the physical world because we cannot describe natural artifacts using those particular elements. The ellipse belongs in these systems because the ellipse is in fact an extended circle. It's like taking the center of the circle and dividing it in two and pulling it out, and then you get an ellipse from it. So they are all closed systems. They are all perfect. They cannot be varied because a circle is a line of constant curvature, no thickness. A straight line is a straight line. A straight line means there's no variation. There's no movement about it. It's totally perfect. And it therefore cannot reflect any system in which change is inherent, like in nature change is inherent. There has to be constant change and transformation. And so this is represented by non-Euclidean geometry. And this is the geometry of nature. Using this geometry, then we can draw what is the first development from the formula which I showed you before, which had the hyperbola on it. That was the elevation of this spiral form. The spiral form, where we were looking at it on the hyperbola, was the distance 1 from there to the center. So it's actually very small scale. We will have a larger spiral at the moment. But this spiral starts at alpha, or alpha infinity, as Viktor Schauberger called it, which is the beginning, and by rotating an almost infinite number of times, or an infinite number of times, seeks always to strive to reach the point, which is omega. So it's moving from the straight line to the point. And this is the curvature of matter, of the descent into matter. And the nature of this particular curve is such that no two parts of it are identical. And so within this also is underwritten not only the discontinuous aspect of evolution, which is the production of individuals, of individual things, but also the continuous movement of evolution into states of higher and higher order. So along this line, this spiral line, every degree, every part of it, the curvature is different. You cannot take a part out here and put in here. It doesn't fit anymore. And so every individuality, all the myriads of atoms, every single thing that exists in this universe can, in a sense, be represented by a small part of the spiral as its characteristic, because there are no two parts of it alike. As you progress towards the center, of course, the velocity increases, the energetic activity increases, and you get closer and closer to God, so to speak, because originally Walter called this the theocentric system, wherein God lay at the center. And the only way, in fact, to reach him was to jump out of space and time. So the curve, as it were, is space-time continuum. The straight line is out of space and time, and so is the point out of space and time. But they are the two bridgeheads from which life springs into physical existence. Interestingly enough, also, this spiral connects the points of the triangle, the square, the pentagon, the hexagon, the heptagon, the octagon, the nonagon, the decagon, etc., 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 etc. And one of the amazing things about this is you begin to learn how nature can divide things up with equal angles. If I can find the thing. Where is it? No, this is what's getting out of context. Just to show you how this form is also, this hyperbolic spiral appears in nature. This is a meteosat photograph. Here you have the diagram I showed you before, and this is virtually the same energetic wall. This is a low pressure system, and again, it's like the tornado. The energy, the closer you get to the core, the greater the energetic content. Again, the same math can be used to explain galaxies. You can have a galaxy much the same as this, and also as I overlaid that galaxy earlier on in the show. Into this too are all the various this hyperbolic cone again can be used to explain all the different frequencies. From ultraviolet, visible light, infrared, radar, and so on, all as questions of wavelength, of distance from the central axis to the outside edge of the hyperbola. If we move in now on the spiral, to go to a closer view of it. We have made, so to speak, one full revolution from alpha, which is infinite distance away there, and we've gone round completely once. We've turned round through 360 degrees, and we arrive at the value of 1, because we have made one total revolution. And at that point, we can say that the string length, so to speak, is 1. We have completed the period of what you might call pregnancy, because before 1 there is nothing. There is no wholeness before we arrive at the 1. And after that, then we enter the world of the physical world. Before that is still transcendental, and from this point 1 onwards, there has become an individuality. Before an individuality, there is only energy. And with a string length 1, after 1 full revolution, we have moved into a position of a half, into a third, into a quarter, into a fifth and sixth. Exactly the same in reflection of the hyperbola which went up in the other direction. So here we would have the distance 1, there would be 2, so the elevation of this would be a curve which goes up in the opposite, in the other dimension. And into this can also be interpreted musically, because the string length being 1, would have a certain tension, and then as we reduced the length of it, the tension would give rise to all the various notes that we're aware of, and it would be just wherever the string length is, gives you whatever the note is, so to speak. And then you find some interesting relationships that in the major notes on the scale, they are always divided by multiples of 15, 30 degrees, 60 degrees between F and G, and so on. And the other half notes are in multiples of 3 or, or 9. So one begins to get certain insights into the patterns of energy by looking it through the spiral form. This is also another one which interprets it in terms of color, that you start with the base tone where you've got the rather darker color. As you move around, then the color becomes a higher frequency so that it's a lighter color, but still going through the full spectrum, so that it begins to teach you how eventually all colors return to the source from which they came, which was white. And also an idea of the higher vibrations of colors that, for instance, clairvoyants and other sensitives are aware of, which are really merely harmonics of the lower ones. This spiral that we saw before is also the spiral by which you can use to divide any angle into equal parts, any number of equal parts. Now, if you've looked at a pineapple, you've seen that there has spirals on it, maybe 13 going one way and 34 going the other way, or on a pine cone, there's 5 going one way and there's 8 going the other way. So how does nature make these beautiful divisions? Because 13, to divide 360 degrees by 13 is a bit difficult, or by 24, or by 33. But if you take this hyperbolic spiral and you want to divide an angle, let's say this angle AB, then you take your compass, you make a mark at the top and the bottom where you want to incorporating the angle, and then with that radius, you multiply that radius 5 times if you want to divide that angle by 5. And once you've multiplied the radius 5 times, then you have this length here, the green one, which then has the value of 1. And you draw an arc from the center to where it cuts the hyperbolic spiral, and you draw a line to the center. Then you reduce the radius to a half, and you do the same, and then you take it to a third, and the same, and a quarter, and do the same, and finally to a fifth, and you divided that angle into 5. And here again is the hyperbola when you connect all those lines together. So it's a kind of mathematics which seems to be very integrated. If you take a section through the hyperbolic cone, then you can get fish shape. This is the hyperbolic cone, part of it there and part of it here. And taking an angled section through it, the flat plane that you can see would have this form. And so there's a bit of the tail of the fish too. If you cut it in another section, slightly flatter, then the egg can be obtained from that. So with this system, it's possible to create any egg precisely and mathematically to determine it. You can design your own egg, so to speak, the one which is most suited to whatever purpose you require. And according to Walter, maybe it was even in the shape of the egg itself that the flight characteristics of the different birds were, because one kern of curvature produced one form, a different curvature on the egg produced a different kind of bird. I don't know if anyone has really made an accurate study of the precise dimensions, but they're all different sizes of egg, and all the birds have different flight characteristics. And so in using this process, I've actually been able to make some eggs. These ones hold about, I think it holds about 5 gallons or something. It was made as a water device. And this shows you a little bit more how you can make sections through these cones. These are various sections taken through the cone, and from these you get a number of different egg shapes. This one, for instance, would be taken. It's difficult to do this without relation to the cone. I'll try and put that back here. No, I think I have to take it out. It depends how pointed the egg is, depends on how steeply you make the cut through the cone. And it doesn't matter where you make the cut on the thing, you can always define it from a mathematical point of view. These are all different egg shapes. And these are the data which correspond to it, so that it does show you that they can be very precisely defined. It's a different one. I'm afraid it went slightly wonky at the end. And there's another one which is more leaf-shaped. So all these can be drawn out of Viktor Schauberger's maths, which again is this very simple form of maths based on the equation 1 over n. Land a spaceship on Mercury and you were using Euclidean geometry, you could be quite a long way away. And I do believe that when they tried to land one of the landings on the moon wasn't where it was, and they had to use up quite a lot of fuel in order to actually get there. And the thing may have been the result of this discrepancy, that the moon they thought was here, but it actually was